All right, good morning, everyone. 9 o'clock, great turnout here in the technical security track talking about identity and access management. My name is Mark Ryland. I'm the Chief Solutions Architect for the Worldwide Public Sector team at AWS. So I have the privilege of hiring and running a great team of technical experts. I try to stay fairly technical myself, although it's hard sometimes. It's a fast-growing organization, big team, but this is an area that I'm particularly interested in, identity and access management. I also have with me today Adam Getty, wave from the wings there, who will be joining us. I'll do about a 25-minute presentation, and he'll do about 20 minutes. Adam is from our partner, Ionic Security. Let's jump right into the agenda here. So I'm going to experiment on you folks today. I've got an identity and access management presentation about AWS IAM that has never been given before. It's all brand new material. I sort of sat down with a clean slate and said, how would I explain this in a nutshell quickly to folks? So we'll see if this works. I'm going to go pretty rapidly, 25 minutes, a lot of material to cover. But I wanted to sort of kind of lay out using sort of a classic sort of block diagram or layer cake, the different layers, the different things, the way they interact. At least give you this, again, it's an overview. There's tons of details that have to be omitted, but hopefully it will be useful. I'll start with the identity side of the identity and access management equation, the principles and users and groups and things like that, and then shift focus to the access side, which is given a set of resources, how do you access those things, how do you control access? And then a very nice segue to the Ionic security presentation, because the sort of holy grail of access management is, okay, I can do all these cool things with identities, I can do all this great stuff with access control, but once data leaves the endpoint, leaves the application, leaves the service that I operate, how do I control the data itself? And Ionic actually brings to the table some very cool technology for access management of data. And so you'll hear all about that. I should mention also that there's a very close partnership between AWS and Ionic. It was announced just a couple weeks ago, collaborating very closely, building some solutions that will enable both public sector and commercial customers who have very high data security requirements to do some really impressive things, which you'll hear about. Okay, so here's the canonical diagram I'm going to use throughout the entire presentation. I've got essentially users on the left side, different kinds. I've kind of roughly divided the world into sort of end users and administrators. Going from the bottom up, the stuff in the blue essentially are the identities, or identity systems, or features or capabilities that are present in the Amazon infrastructure itself, in Amazon Web Services. The darker blue one, web identities, this is sort of built-in trust. We'll get into the details there. And then at the top are identity systems that customers bring to the table that you then use to integrate with the capabilities that we provide. Somewhat similarly, on the right side, at the lower half, you have services that we run, that we operate on your behalf, that you can configure, but you can think of those as protected endpoints where we operate the policy enforcement points, the policy decision points, to use XACML terminology. And we'll talk a great deal more about those details. And then above that, there are systems that operate that are above that sort of layer of the cloud APIs themselves, and use more conventional, traditional technologies like you might have used on premises. For example, how do you authenticate to an operating system? How do you authenticate to an application? If you run a Drupal application on the cloud, it's got a user database, it's got password maintenance and so forth. That's completely above and not necessarily directly integrated with the underlying platform. But we're going to talk about some of those gory details now. And in the middle is the identity access management service itself, as well as a component we'll talk a lot about, the security token service. And then something I won't talk much about today, but there's another layered service there called the Cognito service, which provides identity-related services, particularly optimized for mobile technology. So off we go. So let's think first of all about these kind of built-in identities that are built into the platform itself. And kind of at the base, you have IAM users and groups. Hopefully people are familiar with those. It's kind of the basic thing that's there built in. One of the important things to note about the built-in identities is there's a very clear distinction in our system between an identity and identity proofing. How do you prove that you're user X is very different from being user X. In a lot of systems, those kind of get conflated because often the identity is thought of as sort of like a username and password. which is really a way of proofing as opposed to an identity. In our system, those are very strongly distinguished because for any given user or identity or principal, user principal, you can have different methods for proving that you're that principal. And in particular, if you're using interactive scenarios, you can log into a console with username and password. If you're using software-defined scenarios or command line access, you're using access key, secret key as a way of proving that you are that entity, that identity. And the rules and the enforcement and everything is exactly the same in both cases, but the proofing is completely different. Another thing that's perhaps was announced recently that may not have gotten your attention yet, but Cognito Identity User Pools. This was an extension of the Cognito system, which previously relied on federation as its only way of of coming in and proving you were user X. You would use a federated authentication. Now there's a built-in authentication capability for Cognito. And these Cognito user pools have a whole set of features around users, user properties, password management, password reset, multi-factor, mobile app, or SMS verification. Lots of cool capabilities and features built in there. It's kind of positioned as a mobile solution, mobile app solution, but it would work fine for web-based apps or lots of other apps. So it's just something to be aware of. One of the key things here is there's no need for a separate trust configuration. The system trusts itself. These are built into the system, so when you add identities, there's no way, you don't have to create some sort of link between your identity pool and the core system because the system essentially is creating or emitting these for you. In the middle, kind of lighter blue, are these other modes of the system. And in particular, these are modes in which these are derived identities. So basically, think of it this way. The kind of core root identities are users, but there are modes in which the user's access is enhanced or changed slightly. And so in particular, there's an API called get federation token. I put federation in quotes because this isn't the way the word federation is typically used in the industry. But this enables you to, given a principal, I can create tokens, temporary tokens, either for myself or someone else, and hand those out as what's called a federation token. And with that token, then you can get some access rights. The thing that's important here is you can only downscope the privileges when you create these federation tokens. Whatever privileges the underlying user has that's creating the token, they can give all their rights, their privileges out if they want, or they can give a downscope version, but they can never give more than their own privileges. So essentially the privileges of the temporary token are the user who created it minus whatever they subtracted when they called the API to create the token. The roles thing is very important here because roles are a kind of pseudo principle in the system that can be, I think the terminology is something assumes a role. Somehow something's bootstrapped, it exists somehow other way, and then given the right privileges, it can assume the role. When it's in the role, then the role is a bearer of privileges. And so whoever's ever in that role has the privileges associated with the role. There's two particularly interesting use cases here, one of which I'll illustrate a little later, but for now, let's say any type of cross-account access. This is really important when you're working with third-party ISVs, or even multiple entities, say within an agency or an organization, you have multiple accounts. Role assumption allows you to have access to a different account, with what's called cross-account roles, without sharing credentials. Super, super important. Don't ever give credentials to anyone that you want to access your account. Give them the right to assume a role, and if they have an identity in any other account in the Amazon system, you can permission them to do role assumption. They can assume the role, and when they have assumed the role, now it's as if they're operating within your account. Now everything works as it should. You get logging and auditing, the privileges are fully controlled, and so forth. But the beauty of that model is you're not involved in the proofing or the identity management of that user. You're simply saying, hey, given this other identity in some other account, I'm going to give you some privileges in my account. And you never share passwords, you never share secret keys, access keys, and so forth. So very, very important and very useful. There's another set of trusted identities that are trusted essentially by convention. And that is what we call web identities. So given some well-known sources of identity in the web ecosystem, specifically login by Amazon, Facebook, Google, and Twitter identities, we've pre-configured trust between our system and those systems so that if you come in with one of those tokens, you can transform that into an AWS token, and then you can write create privileges around the federated user. So that's an interesting use case. And then finally, and this is perhaps the most important in some ways for the corporate enterprise government customer, very often they want to bring their own identities to the platform. And this is very sensible. You don't want to have to recreate identities. You don't have to do a lot of synchronization of identities. You don't want to have to do multiple user, password management between systems, et cetera. So in that case, what you do is you essentially bring your own identity in the form of some external identity system that emits tokens, and then you take the token, you transform it to an AWS token using the security token service, and then you make API calls. And so using that model, you can take all your Active Directory users, you can take users that come from a OpenID Connect system and so forth, and create a sane and safe way for them to access resources in the AWS system. Now, this model does require that you create some kind of trust between the identity provider and AWS, because if you walk up with a SAML token that we've never seen, the source before, obviously we're not going to trust that. But if you upload the right, certificates and the right credential documents to our platform, then that will become a trusted provider for the accounts that you associate that trusted provider with. The identity service itself, as I mentioned before, is kind of these three elements. The core identity and access management system itself, it has a security token service, and then the Cognito services are built on top of that and provide some things specifically, as I said, they're useful in sort of web and mobile app scenarios, especially around synchronization of properties for users, and also some analytics around users and how recently they've logged in and kind of some of their access patterns and some things like that. I'm not going to, again, go into that. It's worth a whole long discussion, but I won't do much beyond that. Now, the AWS console is an interesting thing. It's sort of, it doesn't really have any sort of official role in the identity system, and it's just a user interface to the APIs. It calls the APIs on your behalf. You prove who you are to not really the console. The console passes through your credentials to the identity system and decide, the identity system tells the console whether you are who you claim to be. But it does come into play in a lot of scenarios, and especially some of the federation scenarios, it plays kind of an interesting role. So I'm calling it out here as a kind of separate thing in the identity system. So let's walk through a scenario. Given that, I'm going to get to the resources in a minute, but what's the scenario by which I would log in, for example, or call an API, in this case, to access EC2. So let's start this out. So the administrative user, let's say they would log into the web console. Let's assume they log in with username and password, and their system's been configured to require MFA authentication. So the console will prompt you, you log in username and password, it'll prompt you for the token. The console will then call IAM and say, hey, is this user part of this database for this account? If the answer is yes, the user will be authenticated. Essentially, they'll have access to the console. Now, the console, to do the MFA portion of your authentication, it uses temporary credentials, because you can write policies that say this user must have authenticated within the last 30 seconds or 3 hours or whatever you want. You can write those as policy conditions on the resource side. And therefore, the console will create temporary credentials on your behalf. You don't have to think about it, but it's using, behind the scenes, it's using temporary credentials. And specifically in the MFA case, it will take your base credentials, take your MFA token, essentially create an enhanced token that it will then use for calling all the APIs from then on. Now we're going to transition to this across sort of boundaries, because when I do launch this EC2 instance, I need to log into the instance, okay? And at least today, now these things are changing and enhancing over time. We'll talk more about that. But when you authenticate to the operating system, you're using traditional SSH authentication, public key, private key authentication. You're not using something specific to the Amazon system. So you're using an existing technology for operating system authentication. But how do you bootstrap that? Well, the way you bootstrap that is you agree with the identity system which public key and private key you're going to use, and then the system will deploy the public key onto the instance as it launches it for you. So now, as you can see from the rest of the steps, when I go, the console calls the EC2 API on my behalf, but there's an identity little piece sitting there in that API call. Namely, it's saying use this public key when the instance launches as the method by which the user will then later come and log into the instance. Okay, so kind of behind the scenes, magic happens, instances are launched, public key deployed onto the instance. Now, when you go to log into the instance, you're doing a standard SSH login at that point. There's nothing specifically to do with the Amazon identity system. The system has helped you, it's bootstrapped, but at that point, you're just doing a normal SSH to the instance. So one of the points I want to communicate very strongly in this presentation is that there's different layers to these systems, and the layers interact in sometimes relatively complex ways, but I think it's worth thinking through some of those layers. So that's what we're going to try to do today. Let's give you another scenario. This is a similar operation. I'm going to launch an EC2 instance, but now I'm going to use my Active Directory, on-premise Active Directory or one in the cloud, and I'm going to ask, say, Active Directory ADFS for a SAML token and use that to authenticate to the console instead of username and password. So in this case, we support what's called IDP-initiated authentication. So you actually start with your authentication system to get your token. You'll get back a SAML token. You call the security token service with that token. In this case, it's a web URL with a post and the right, SAML token exchange using web calls. And the security token service will give you back a URL that has the token essentially embedded in it. And then with that and a redirect, you go to the console. The console will then log you in, and now you're logged in using a role, because SAML is the identity that comes from SAML. It uses role assumption as its model for creating this temporary principal that you operate as when you're in the AWS system. So now I'm logged into the console. I'm a different user, by the way, than I was in the previous case. I might have the same privileges, but in this case, I'm in a role at that point, and the role is an object. It has a name. It has an underlying identity or an underlying UUID, so that you can change the name, and the identity of the object's identity never changes, and then it has a set of privileges associated with it as well. In this case, one of the privileges is to launch EC2. So in this case, the same from here on, it's the same drill. Identity system will, with your help, deploy the certificate onto the EC2 instance, launch the instance, and then you log in with a normal SSH login. Let's try a slightly different scenario. In this case, I'm not going to use the web console. I'm going to use a command line tool to launch an RDS instance. RDS, like EC2, typically has an out-of-band mechanism for putting the administrative password and username and password onto the database. And then you log in with a conventional MySQL login or Oracle login or whatever it may be. So in this case, I'll go to my SAML endpoint, get back a SAML token, call the STS, directly now using command line tools. I'm not using the console. Security token service, I trade my SAML token in, I get back an Amazon token. The command line tool then has some little features that enable you to essentially assume the role that token represents and then call the API, in this case RDS. Now again, this API call, the create an RDS instance, includes this phase transition component, which is you tell the service what you want to use as the administrative username and the administrative password. So once that's told to the system, it will launch the database as a managed service. But when you go to authenticate to the database itself, you're not using Amazon technology, you're using database technology. Okay, so again, you cross one of these boundaries. Finally, a couple more scenarios. So this is a very common, now you might say, so far we've been doing administrative scenarios, but are there end-user scenarios? The answer is yes, there's a lot of interesting end-user scenarios, and we could go on and on about these. I'll give you one very common one. Many mobile applications want their users to directly upload or download files from S3. It's this wonderfully highly scalable, worldwide available, web addressable object store. So what the heck, why would I run a fleet of web servers in order to have file upload and download? I would use S3 natively in that case. But I needed to use it securely, right? I need it to be so that only a certain user can do certain operations. I want to lock it down. So in that case, the code running on the mobile device, an end user device, would go to a web identity provider, let's say log in by Amazon or Facebook, go through an authentication dance with that service, get back an OpenID Connect token, or one that's similar to one of those, since the major players all have their little variations on the standard. Take that token, go to STS, say, here's a token proving that I'm Joe, give me back an Amazon role that corresponds to Joe. You get back the Amazon token, and then you use that token to sign your request to S3, you make a direct call to S3, and you have access, secure access to anything that the author of the application wants you to access in the S3 storage system. Okay, and finally, here's another role usage that's very, very important, and that is, there's been from early days in AWS, the customers said, Jay, one thing I very commonly want to do is I want to be able to log in to, I want to be able to access AWS APIs from EC2, but I don't want to have to manage getting the credentials onto the virtual machines that run in the virtual machine service. So role assumption allows you to do that. Role assumption by the EC2 instance. So in this case, I would use the command line interface, prove who I'm a user, I have a right to launch an EC2 instance, launch the instance, but now I've told the system, run this instance in a role that I've designated. Now the system will provision credentials automatically onto that role, AWS credentials, and the EC2 instance can now call APIs, and the privileges it will have in calling those APIs are the same things as what you've configured in the role itself. So what about on the resource side? Again, I'm going to have to go at high speed to get through my material here, but on the resource side, on the lower part, you have the resources that are protected by the IAM system itself. So you have, the sort of base infrastructure APIs for launching EC2 and so forth. Those create things in your environment which you might authenticate to separately, as I've already shown. You have these things we call abstracted services that you always access with APIs. There's no separate data plane and control plane. The same endpoint is used for both object creation and so forth, but also access and usage of the service, and that includes things like S3, DynamoDB, SQS. And interestingly now, user-defined applications are capable of being protected by our identity control system. So for example, if you write a Lambda function, you wrap that with a IAM-based policy that controls access, similarly with API Gateway. So you're starting to see, just a couple years or a year and a half ago, there would only have been the lower two blue boxes, but we're moving kind of up the stack, providing this identity system as something that you can use for the applications and code that you write in these services. So just one more quick tour on policies. Policies can, this is something that does not, in my opinion, not super well explained in our documentation, but there's basically 3 places where access policies can live. One is you can have policies associated with users, with principals. That's kind of the most common use case. It's the one that I think most people are familiar with. One that's a little more subtle is you can have policies associated with resources. Not all of the services, but some of the services have resource policies, and that means that regardless of the identity who walks up and accesses it, it has to pass an access check based on the resource itself, which has its own resource management capability, independent of users. Now the 2 policies, well actually, let me do the third. The third kind of policy that can be present in an access decision is in the temporary token itself. When you create the temporary token, the caller of the API that creates the token can add a policy to that, and that policy actually gets encoded into the session token itself. So now, if I go to access a resource, I'm actually dealing with potentially 3 policies, all of which must allow the access in order for the access to occur. If any of them are denied, the access is denied. If they're all allow, the access is allowed. So for example, S3 access, the policy on the upper left is a role policy, which says allow a principal in this role to do one API call, get object. It can do it on any resource in the system, that's the star, but that's the one API the role, the principal is allowed to call. On the right side, there's a resource policy that S3 has, which says, I don't care about the principal. Now you can write a principal instead of star, and notice that in the principal, on the policy on the left, there's no principal written out. It's because the principal is implicit. The principal is the principal that the policy is associated with. In a resource-based policy, you have to explicitly say principals, or you can say principal star, but you have to have something there because the resource doesn't know who the principal is going to be when this access decision is made. And then finally, in the lower left is a temporary token policy, which is I've kind of artificially created. This actually wasn't a great example. I realized later I could have used something like a condition that says only when this IP address is the source IP, allow this access. I used a time-based one, but then I later realized, actually, that's not a good example. All this works because the tokens themselves have time associated with them, right? So I can, when I create the token, I can give it a time bound. But the point is that for proper access to work, all three of these access policies have got to work together to be successful. So the upper one, as I said, no principal is implicit. Resource policy has the principal has to be there. Just an example of some of the services that support resource-based policies. And then finally, this is temporary token itself can include a policy, and all three must be present in order for the access to succeed. So let's give a couple more scenarios. In this case, I'm going to use an Active Directory user. In this case, there's actually code running there that's going to create a token explicitly using code that the user has written or that the administrator or the application has written. It'll create that security token with a policy embedded in it. I'll access S3, and in this scenario, all three of those policies would have to agree to allow access. Now finally, the last layer that I'll go through quickly is this kind of operating system, network operating system layer, which is pretty much the same as what you have today on premises, but we give you some additional capabilities that make it useful. It's, log into your Windows server, it's log into your Linux server. It can be running Active Directory in the cloud or extended to the cloud, and so you have single sign-on to your instances using Active Directory. We even support Linux-based single sign-on with a pluggable module that enables that. And again, this is very similar to what you'd have on premises. And finally, you have applications, and applications can integrate to these lower layers, or they can be separate. You could be running a Drupal site that has a completely separate authentication system, nothing to do with anything of the things we talked about. Or you can use, I'll give an example. Let's say you're running ArcGIS in the cloud, and your users walk up to ArcGIS, they authenticate using Active Directory. Now you may be running a copy of our directory service, which allows you, as a managed AD running in the cloud, the ArcGIS system would authenticate the user to that. It could be used as an extension of an on-prem AD. So in this case, I'm showing a callback to the on-prem AD to authenticate the user. Now at this point, you're done, and the user's authenticated, they can use the application. But again, the way we can kind of cross some of these boundaries is ArcGIS itself. Now, let's say the system that actually does this, it stores some of its pre-computed objects in S3, and it wants to be able to pass out a secure URL to the user, so the user's browser downloads the object directly from S3 rather than coming through the web tier of the application. So in that case, the application would pass back a token to the user. Well, first it would create the token, pass it back to the user as part of the web page that's downloading, and then the browser would do a get directly on S3 and pull that data in. So now, again, you've crossed the boundary, but this time you started with traditional systems and you've dropped down into the cloud system. So, very rapid tour through the identity system. I hope that was helpful as a kind of general overview, and I want to introduce Adam Getty to come to the stage and talk about Ionic and some of the really cool technology that they've built to work very well with the AWS cloud. Adam, welcome.
Thanks, Mark. Really appreciate it.
Yeah, thanks.
Hey, it's going to be a tough act to follow, that's for sure. Everybody hear me okay? Fantastic. So my name is Adam Getty. I'm the founder and CEO here at Ionic Security. Do not let that CEO title fool you. I was also the CTO for the first 4 years, so I'll try to get kind of relevant and practical here today. At Ionic, we have a saying, in math we trust. And today we're here to discuss what the world would look like when the right math is implemented in verifiable ways and then is managed in a high assurance fashion at web scale, how you can use that math to enable first and last mile high assurance data security. Basically, how do you take these strong identity and access management concepts that you have in your infrastructure and applications and apply them to the generation of your data, regardless of whether that generation takes place inside of your on-premise infrastructure or in trusted infrastructure such as AWS, and then ensure that those principles and those security controls remain intact even as that data departs from your trusted infrastructure and your trusted applications and is then taken possession of by other third parties. We live in a world today that has never been more connected or more distributed than ever before. In this world, every organization, commercial to public, relies on strong collaboration with partners to accomplish its mission each and every day. For the rest of this conversation, we're going to talk about a simple scenario. one in which a federal agency needs to collaborate with other state, local, and federal agencies, all the while still needing to ensure that their data is only accessed by appropriate humans, infrastructure, and applications, all the while those things are in the appropriate locations. The goal is quite straightforward. We want to enable a function of securely and appropriately collaborating. So we're going to discuss today how you do that, and how you do that in a verifiable web-scale fashion. Mark just discussed how inside of AWS's trusted infrastructure, you can enable robust and connected identity and access management capabilities. However, Mark also discussed how you can take those concepts and bring them into independent services within the AWS ecosystem. Today, you have your own infrastructure that's on-premise and has been managed and maintained over many years. It also has strong identity and access management capabilities and concepts. Bringing these two worlds together has never been easier than before. Mark just walked us through some great ways we can cross these boundaries simply and programmatically. Additionally, technologies like AWS Direct Connect enable even the communications between your on-premise infrastructure and AWS are highly secure. However, this equation dramatically changes when we introduce an additional agency. So in this case, we are introducing another federal agency. They bring with them their own infrastructure footprint. They bring with them their own connectivity, and they bring with them their own identity and access management models. The same is true for every state and local agency that needs to collaborate as well. Each of these agencies is also continuing to innovate for its workforce. So they all have enablement of mobile and field workforce. Each of these infrastructure components are all participants in the data creation and consumption ecosystem of each other when they are collaborating. So the question then becomes, how do we take the strong concepts that we've put into our own infrastructure and into trusted infrastructure such as AWS and extend them from the infrastructure and applications to the data itself as it departs from these trusted ecosystems? The rest of this discussion is going to be talking about how we actually go about accomplishing this in practice, leveraging AWS and Ionic. Just because this world now is distributed, has a bunch of different actors, and is connected via different networks and technologies, it doesn't reduce the fact that we still need to only ensure that data is accessed by the appropriate humans, applications, infrastructure components while they're in the appropriate locations. The complexity that's been introduced is because there are now ad hoc collaborators that live in different worlds under different constructs. We cannot predetermine who all these infrastructure, application, humans, and locations might be. So we need a system that can reconsider these components just in time and constitute a temporary decision for that very particular set of context. And this system needs to be able to cross organizational boundaries. And we need a world in which everything is distributed that these scenarios fail closed if they're not satisfied. In a world in which we rely on infrastructure and application security to keep our data itself safe, when those things are compromised, either by a rogue insider or a very advanced outsider, under any conditions, they fail open. We need a system when, since we can't control who and what is managing our infrastructure and applications end-to-end with our data, that the data itself is smart enough to fail closed when it finds itself in an awkward situation. So if we're going to start with data, we should talk a bit more about what is data. Traditionally, we think about data as black and white. It's unstructured and structured. It's documents, it's emails, it's telemetry coming off our SCADA systems, it's information in an application or a database. And if we really start to inspect that, we realize that even though this is just a subset of each of these worlds, in reality, nobody in this room believes any of this data that's on the top or on the bottom lives exclusively in that world. That Office document gets uploaded to Salesforce, which puts it into an Oracle database, which has custom applications connect to it, that then gets used by a user to run a report across 1,000 documents, which gets put into a PDF, gets pulled back out, put into your email client, sent to my Android. It changed hands from structured to unstructured multiple times in just a few minutes. And that's even before we start getting into the concepts of Is this an internal user? Is this an external user? Is this my infrastructure? Is this hybrid infrastructure? Is it regulated data? Is this information classified? All of these things in a distributed world where we have so much data transforming from structured to unstructured in so many different systems, it is impractical to believe that we can preordain and predetermine all the rights we might need in the future. So we really need to think about this problem differently. The first thing we believe is you need to think about this problem whereby data is no longer structured or unstructured, documents or entries in a database. It's a digital asset with a classification. That classification could be quite simple, public, internal, or it could be quite robust, like the US intelligence community's classification framework. We also need to evolve our view of what a user is, and Mark touched on this quite a bit in his previous discussion. Users are not just humans. Users in this distributed world are also infrastructure, their applications, and their locations. There's no human that interacts with your digital asset unless they're inside of an application on some infrastructure while in some location. But there also might be applications on infrastructure and locations that make and interact with your data without any humans involved at all. So we need a system that understands this as a user concept. But once we understand and define data as simply classifications and digital assets and users as a combination of any or all of these components, rights are really easy. It's a function of this data is attempting to be accessed by these users. Should it or should it not happen? However, in a digital world, managed rights are no different than the law. They're only as good as their enforcement. In a digital world, we've come to liken, as a collective here, that the way we go about enforcing rights on digital assets is to take those rights and take that information and encrypt them. We take all of this data and we say, hey, let's just encrypt it. The challenge with just encrypting the data is that now it's encrypted. We can't see it, our users can't see it, and our partners can't see it. In an encryption-based world, we have put ourselves in a corner. We know that to keep data safe and enforce rights, we'll encrypt it and only let the right users and systems decrypt it. But for the last 25 years, we've built systems that are so siloed, so tailored, so proprietary to our needs, that we've made them so cumbersome to manage that now we actually just go about making decryption really easy. So we encrypt an entire database and say anybody that comes to the front door gets access to the whole thing. We encrypt entire file systems and say if you get root on it, you get all my files. We've made it really easy to decrypt, but we've not really actually solved our data access management problem because now we encrypt lots of data with a few keys and then make it easy to get to those few keys. So the real problem is we need to innovate on decryption management. When we talk about innovating on decryption management, what we need is a system that understands how to give us rights back to our data, our infrastructure rights back to our data, and then just the right amount of rights to just the right users and just the right partners under just the right circumstances. And we need that to be a temporary decision, as Mark mentioned earlier. It's not always yes or always no. So what would that system look like under the hood? First and foremost, it needs to understand our data and our users. However, in a world where we are reliant upon collaboration to be successful, it need not just understand our users and our data. It need to understand the data and users across all of the collaborators. And it also needs to understand any combination of data and users amongst those collaborators. To take this a step lower, if we look at a system that can enforce rights with the definition of data and users as we've defined, it's doing something quite simple. It's making a determination. What data that's currently encrypted should become decrypted under what circumstances for which users? And under the hood of that, it's actually not all that complex. In a world where we don't pair keys with big assets like users or devices or infrastructure, we pair them uniquely with each individual data object, this system is saying, hey, which digital assets are protected by which keys? And then it's saying, based off policy, which can be multi-source, as Mark just mentioned, all things need to be satisfied, any one deny should say no to all. It needs to take that policy, and it needs to understand which digital assets of what classifications should gain access by which users under which circumstances. It's pretty straightforward. However, to get this right in practice is not easy. We've been trying to do this for a long time. Most folks in this room will not see this as new ideas. But there are new ways to go about being successful implementing these ideas at web scale. So first and foremost, for this to work across collaboration boundaries and enterprise boundaries, every single digital asset, every single key, every single policy, every single user, knowing that users are defined not just by humans, needs a globally unique identifier. We are talking about trillions of objects. It's a very different equation from millions of PKI certs. Secondarily, we do need a global orchestration service. It doesn't mean that it's centrally managed or centrally owned, but it does need to be global. And this service needs to be trusted. And the only way it's going to get trusted is that every single one of its actions is independently verifiable by every single participant in the ecosystem. Secondarily, it also needs to be federated, not just in its connectivity to everybody, but in its understanding of how each organization asserts and manages rights and identities within its four walls. And then it needs to be able to translate that information on the fly to a common conversation amongst all participants. But then last but not least, because this thing is managing and orchestrating your most precious assets, your data protection keys, and it's doing that across unknown and not predetermined infrastructure to not predetermined users, it itself needs to be able to verifiably show that it cannot see your keys even though it's moving them around, and that no superfluous or unassociated actor in any of these equations gains access to those keys even though they're moving around infrastructure you previously had never heard of. We call it blinding, and to do that right at scale is actually quite challenging. And then this system, because it's relying on managing whether or not encrypted data should turn into decrypted data, what it's really managing is keys, but doing it quite well at large velocity and at highly distributed fashions. So it needs to be able to talk to key infrastructure from a generation and a storage perspective that's going to look different from one organization to another organization. That infrastructure might be backed by one agency with on-premise HSMs, and as well, for certain classification and certain use cases, by cloud HSMs. Some organizations might only use HSMs in their data centers. Some might only use cloud infrastructure. Some may not be sophisticated enough or have a need to use HSMs. Yet this system needs to understand all of these equations, all of these attributes, and be able to commonly orchestrate and make decisions. The system needs one more thing, though. Your data today is highly portable by design. It's generated in many different places, consumed by many different actors under many different circumstances. So what we need is a portable, flexible, and verifiable data protection and identity and access management protocol. We need something that can live exactly where your data is generated and be exactly where your data is going to be consumed without any compromise. This capability needs to be as portable and as common as your data itself. Anything less does not help you accomplish your goal. So for the last 4 years, we at Ionic have dived deep into these exact problems. And what you're looking at right now is not meant for consumption at the moment, but it's a high-level overview of the 3 big moving parts. On the right, an actual highly verifiable, highly assured implementation of a data protection and identity access management protocol. In the middle is a global orchestration tier that is independently verifiable, web scale, and blinded to all of the privileged information that it's orchestrating. It's ionic.com in this model. We stamp out another serial number for different customers, like our military customers, ionic.mil, so forth and so on. And on the left is our patented key grid technology. It is the technology that allows for key generation and key storage to live in any domicile under any configuration, yet have common ways of asserting classification rights and orchestration of those keys in a high assurance fashion across all participants. So to recap, what we're enabling is the ability for you to simply define rights as I have data and I have users, should those two things intersect. And doing that in a way that is common and portable across every major operating system, already built in and capable inside of all of your favorite applications, and connected to your favorite services. But equally important, what you're actually enabling is your organization to finally encrypt all of your data that is most valuable and most sensitive, and separate the ability to decrypt that information from the infrastructure and the application identity and access management models, such that you can render highly privileged system administrators, whether they're internal to your infrastructure or internal to service providers like AWS, you can render their ability to see your data opaque. And they can administer the systems. They can run away with the systems, but the data itself and the access rights to it is logically separate and managed independently. You're also able to take all of these capabilities that we, out of the box, have built into all the OSs and all these apps and all these services and bring them into your own proprietary application stack. All of this was done by using our cross-platform build SDKs, talking to our widely and publicly available APIs. We operate our .com instance of Ionic as a highly certified and web scale and capable as-a-service tier. We also have taken the crypto module, which is the reason why it's here in red. And yes, we have a FIPS 140-2 level 1 implementation for default. But we have a lot of customers that also have their own crypto needs with different algorithms under different circumstances. So we've abstracted the crypto modules so you can drop in your own cryptography as needed, where you need it, and the rest of the system still functions. We've delivered this over the last 4 years at global scale. We have over 2 million active seats across the global 100s in the United States and in Europe. We have customers ranging from customers like Goldman Sachs to the United States Department of Defense. We have successfully delivered Ionic in practice at scale inside of 8 different highly regulated verticals. And we have already processed tens of billions of production API requests against the platform for our global customers. At the end of the day, AWS and Ionic have collaborated to extend the high assurance and robust identity and access management philosophies that are capable and built into AWS down to your data as it now departs from both AWS and your own infrastructure. And we've done that in a high assurance fashion, and we do it at a scale with federation that actually enables your business to be successful. It enables this collaboration because it understands these rights, and it can orchestrate them across these boundaries. It enables first and last mile high assurance data security. And if you'd like to learn more, please visit ionic.com, as well as myself and AWS's Director of Government Solutions, David Knowlton, will be sticking around for a little while after this talk to discuss more. We appreciate everybody's time here today. Hopefully it was not wasted.